In this section, we're going to be discussing circles. And although circles come in lots of different sizes, their shape is constructed in the same way. Their shape is constructed by finding all of the points, let's call the points x, y, whose distance from a fixed point, we'll call it the center, is always the same. So in this case, the distance from the center to all of these points, x, y, around our circle is always 5 centimeters. So circles are always constructed the same way. They have the same distance from a center point, from a fixed point. Finding this distance from the center to all of our xy's around the circle is going to be crucial in talking about circles. So before we get into circles, we need to talk about something fundamental to circles, and that is the distance formula. Let's say that we're asked to find the distance between two ordered pairs. I'll call them P1 and P2. So let's say P1 is at the ordered pair 1, 1. And let's put P2 at the ordered pair 4, 5. Okay, so P1 is here at 1, 1, and X is 4 and Y is 5 is way up here at P2. And the distance between them will be given by this line right here. We'll find this distance. Okay, so in a minute, I'm going to give you the formula that we're going to use, the distance formula, for finding the distance between any 2 points at all. But for right now, to show you where that formula comes from, I want you to notice this. This distance line right here creates a hypotenuse in a right triangle containing those 2 points. So if I were to draw in the other 2 sides of the right triangle, we know from Mr. Pythagoras that we have the relationship for A, B, and C, the hypotenuse. A squared plus B squared equals C squared. And if we look here, A along the bottom is 1, 2, 3 units long. B is 1, 2, 3, 4 units long. So if we're looking for our hypotenuse, we've got, let's take the square root of both sides. So that just tells us what C is. And I'm going to write C on the left-hand side. The square root of 3 squared plus 4 squared, which is 9 plus 4, 16. So we get the square root of 25. In other words, our C is 5. So let's analyze really quickly how we got 3 and 4, how we calculated it. Well, 3 and 4 are A and our B. This is how we came up with them. 3, we counted, right? There are 1, 2, 3 units here, or we could have subtracted. We could have done 4 minus 1 gave us our 3. And likewise for the B, sure, we could have counted, but what if they don't end up on whole numbers? We also, for B, could have done 5 minus 1 for B, or the top one minus the bottom one. So let's extend this beyond the specific numbers, 1, 1, and 4, 5, to x's and y's. So let's call our P1 now x1, y1, and our P2 x2, y2. And take a look at what we did to the 1, 1 and the 4, 5 so that we can extend it to a more general case. Okay, so let's go back to Pythagorean theorem. C squared equals A squared plus B squared. and we square root both sides to get c equals the square root of our a squared plus b squared. And that c is our distance. That's our distance. Okay, so let's take a look at the a. A came from 4 minus 1, right? That was the distance along this side. Now the 4 and the 1 from our P1 and our P2 was the second x value minus the first x value. This distance right here was the second x value minus the first x value. In other words, for our generic case, x2 minus x1. x2 minus x1. But it had to be squared for the Pythagorean theorem, so we'll square that. Likewise, the b came from, it was 5 minus 1, and if you look at our points here, that was the second y value minus the first y value, so y2 minus y1, and we squared it from the Pythagorean theorem. So y2 minus y1, and it's squared. And here is our distance formula. Let's practice that with a couple of problems. Let's first find the distance between the 2 points P1, given by 3, negative 4, and P2, P2, given by negative 7, 2. Okay, the distance formula we're going to use, I'll copy it down from the previous page. The square root of x2 minus x1 squared plus y2 minus y1 squared. And that just comes from the Pythagorean theorem. Okay, so we'll identify our x1 and our y1, our x2 and our y2. And when we get our distance between these, we'll plug these in. First thing squared, second thing squared. Okay, so x2 minus x1 would be negative 7 minus 3. Negative 7 minus 3. And y2 minus y1 would be 2 minus negative 4. 2 minus negative 4. So when we perform that subtraction, negative 7 minus 3 is negative 10. 2 minus negative 4 is 6. And we have 100 plus 36. Or 136. You are 100% of the time always expected to simplify your square roots. 4 goes into the number 136, and it goes in 26. Oh, I'm sorry. No, it doesn't. It goes in not 26 times. It goes in 34 times. So this would be 2 square root 34. Very cool. Let's do one last one. So in this one, let's find the points between P1 is 1, negative 3. And here I'm going to be tricky. P2 is just the point X and Y. Okay, sure. All right, so our distance formula, we'll plug these 2 points into the distance formula. Let's see, so x2 minus x1, let's label these guys. This is going to be x1, y1, and x2, y2. So our distance is going to be the square root of x2 minus x1 in this problem is x minus 1. X minus 1. And y2 minus y1 will be y minus negative 3. Okay, so this distance, that's not a number, not satisfying. This distance is given by x minus 1 squared, and y minus negative 3 is y plus 3 squared. Okay, there's our distance. Okay, here's where I'm going with this. A circle, remember, is defined to be all of the points, we called them x, y, that had the same distance. For this circle right here, the distance is 5 centimeters. They have the same distance from a fixed point. So let's say that this fixed point in the middle, our center, let's say the center is given by the ordered pair 1, negative 3. You know, just like in this problem here. Then the circle would be all of the points that have the same distance from 1, negative 3. All of the points whose distance in the distance formula would give the same value. In this case, the d is 5. So this circle here would look like d is always 5, the square root, x minus 1 squared plus y plus 3 squared. And usually when we're writing circles, we do two things. We don't write the square root in anymore. We square both sides. So let's do that. We'll square both sides. And we write when we square this side, the square root goes away. We write the x minus 1 squared, y plus 3 squared on the left usually. And then the 5 squared is 25. We write it on the right-hand side. So what this gives us here is a circle whose center is at 1, negative 3, and whose radius I'm running out of room, was not 25, but it was 5, because that was the distance from the center out. Okay, let's summarize this. The standard form for an equation of a circle whose center is at HK and whose radius is R is given by x minus h squared plus y minus k squared equals r squared. It comes from the distance formula, which way back several minutes ago came from the Pythagorean theorem, but this is the formula that I want you to remember. And this is the formula that we're going to use to do our practice problems. So let's find the equation of a circle with the given properties. Let's first do center is at negative 5, 2, and the radius is 3. Okay, the equation of this circle would be x minus negative 5 squared plus y minus 2 squared equals r squared equals 3 squared. Or, in other words, x plus 5 squared plus y minus 2 squared equals 9. Our center is at negative 5 and 2. That's our h and our k. And our radius, don't forget to take the square root. The radius is 3. Okay, let's do one more here. let's find the equation of this circle. Okay, so remember, we need to have the center, the HK, and the radius. So looking at this circle here in our graph, the center seems to be at -2, -3. So our center is at -2, -3. And the radius, heck, I could do the distance formula, but man, it's just 2 units, right? The radius is 2 units. So r equals 2. Cool, so plugging that into our formula, we have x minus -2 squared plus y minus -3 squared equals 2 squared. In other words, x plus 2 squared plus y plus 3 squared equals 4. Cool. In some of your problems, you're going to be asked to multiply this out. So if I scooch up and give myself a little bit more room here, if you have to FOIL this all out, it looks like this. It would be x plus 2, x plus 2, and then we'll multiply that. Same with the y plus 3 and the y plus 3. And we'll get x squared plus 4x plus 4, y squared plus 6y plus 9 equals 4. And combining our like terms, x squared plus 4x plus y squared plus 6y. And if I take the constants, the 4 and the 9, and move them to the other side, I might have it equal to -9. So what I don't like about this way of writing the equation of a circle is I can't see as clearly as I did up here the center. The center is very easy to see with the parentheses form. -2, -3, and the square root of this number is the radius, the 2. In this one, it's much harder to see. So in the next chunk of problems, when we go from the equation back to the graph, the ones written in this form will be easier to do. The ones written in this form will take a little bit more work. So let's practice those. I want to do one more quick example before we go on to the next chunk of problems, because I don't want to give you the impression that all of our numbers are going to be pretty. So let's do one last one. Let's find the equation of the circle with the center given by 2 pi and 5/2, and the radius given by the square root of 19. Okay, here we go. So remember, we're going to use this equation up here for our center, our equation of our circle. So this will be x minus 2 pi all squared plus y minus 5/2 all squared equals, and I'm going to write this step in, the square root of 19, and then we have to square that. Okay. It's actually not that bad. The square root of 19 squared is just 19. So the equation of our circle is x minus 2 pi squared plus y minus 5/2 squared equals 19. Okay, so remember, if you're looking at the equation of the circle, this isn't the radius. This is the radius squared. And if you're looking at the radius, in order to get the equation, you have to square that number. So just remember, this is an r squared and not just an r. Okay, first problem. Let's find the center and the radius of x minus 4 squared plus y plus 1 squared equals 16. Okay, so remember, standard form of our circle, x minus h squared plus y minus k squared equals r squared, where the center is at h and k, and r is the radius. So for this problem, The center, don't forget to change the signs. The center must be at 4, -1. And the radius, don't forget to take the square root. The radius must be 4. So if I were to draw that picture, I would get the center is at 1, 2, 3, 4. Y is -1. Here's the center. Radius is 4, means I'm going to go up, down, left, right 4 units. So 1, 2, 3, 4. I'm up here at 3. 4 units to the right. 1, 2, 3, 4 puts me at 8. 4 units to the left puts me back on top of the y-axis. And 4 units down. 1, 2, 3, 4 down here. Okay. All right, I'm going to do the best I can to draw a circle. Good luck, Mary Beth. Nope, not really. Close enough. Okay, there's our circle centered at 4, -1, radius 4. Let's do another one of these. Okay, let's do now, find the center and the radius for x minus 1/2 squared plus y minus 1 squared equals 1/4. Okay, so the center must be positive 1/2, positive 1. Positive 1/2, I'll put it here. Positive 1, we'll put here. There's our center. And the radius, don't forget to take the square root, is 1/2. Okay, so starting at the center, we're going to go up, down, left, right 1/2 units. So let's see, that'll take us, if we go down, that'll take us here halfway. To the right will take us over to 1. And to the left will take us back to the axis, the y-axis. And then up will take us to 1.5. Best I can. Better than the last one, I'm going to draw a circle. Cool. Circle. The radius is 1/2. And the center is at 1/2, 1. Cool. Okay, let's make these a little bit harder. Let's sketch the circle given by x squared minus 4x plus y squared plus 6y equals 87. Crud. These are in the form that doesn't have the parentheses in them, so I can't just look and easily see what the center is. And 87 is not going to be the square root or our radius squared. So here's what we need to do. We need to complete the square in order to find the center and the radius. I sense we're going to need some room, so let's scooch up the screen and do that. Okay, so here we go. X squared minus 4x, and then I'm going to leave some room there, plus y squared plus 6y, leave some more room, equals 87. So remember, when you complete the square, take the number next to the x, divide it by 2, and then square that result. So -4 divided by 2 is -2. -2 squared is 4. And I want to add that to the end of the x's. Okay, there's something I like and something I don't about this. First thing that I don't like is you can't just go adding 4s wherever you feel like, so we have to balance our equation and add 4 to the other side. Okay, that's taken care of. Now what I do like about this is x squared minus 4x plus 4 factors And it factors to x minus 2, x minus 2. Or in other words, x minus 2 all squared. Cool. Let's do the same thing to the y's. So for the y's, again, I'll take the number next to the y. 6 divided by 2 to get 3. Square that to get 9. And that number, balance, I'll add both sides by 9 with 9. Okay. Let's see. Y squared plus 6y plus 9. Ooh, that factors to y plus 3 squared. And if I add up 87 plus 4 plus 9, I should get 100. Wow, that's so much better. Now it's in the correct format for a circle. I can see that my center is at 2, negative 3, and my radius is 10. So my center is at 2, negative 3. And the radius is 10 in every direction. So I have a rather big circle that I'm approximating, where this would be 10 units for the radius. Okay, let's do some more where I think you get the idea with the sketching the circle, where we just find the center and find the radius. Let's do it one more of these. So let's find the center and the radius for the circle given by 2x squared plus 16x plus 2y squared equals 18. Okay, same idea, have to complete the square to find the center and the radius. We have one major problem. We have these 2's in front of our x squareds and our y squareds. So the first thing we need to do is divide every single term, both sides of our equation, by 2. So that'll give us x squared plus 8x. I'm going to leave some room for the completing the square. Plus y squared equals 9. Very cool. Okay, now we can complete the square. So 8 divided by 2 is 4. 4 squared is 16. And I'm going to add that to both sides. Now, for the y squared, there is no y term, so I don't have to complete the square here. I can done completing the square with the x's, and these will turn into x plus 4 all squared plus y squared equals 25. So my center is at negative 4, 0, and the radius is 5, the square root of 25. Before we can totally finish our discussion of circles, there's one more formula that I need to give you, and that's the formula for the midpoint between 2 points. Think of the midpoint as kind of like the average or the halfway point. So the midpoint between 2 points, x1, y1, and x2, y2, is given by the formula, think average, x1 plus x2 divided by 2. And y1 plus y2 divided by 2 gives us the y value. So just as a quick couple of examples, if we had to find the midpoint between the ordered pairs, I don't know, let's do 3, negative 1 and 5, 2. The midpoint would be 3 plus 5 over 2. So find, basically, I think of it as the average. 3 plus 5, so add the 2x values, divide by 2. And same with the y's, negative 1 plus 2 divided by 2. Give us some room here. So that midpoint would be given by, let's see, what's that, 8 over 2? And 1 over 2? In other words, 4 and 1/2. Okay, let's do one more quick one. Let's say between 7, 6, and negative 1, 4. Okay, so the midpoint would be 7 plus negative 1 over 2, and 6 plus 4 over 2. Okay, so that's going to be what? 6 over 2 and 10 over 2. So that midpoint is 3 and 5. Cool. Okay, let me show you where you're going to use this in your circles homework. We're going to find the equation of the circle with endpoints of the diameter. Remember, the diameter is twice the radius, given by, you might recognize 7, 6, and negative 1, 4. Okay, I'm going to draw a picture for you of what's going on. You don't have to have this picture to do the problem, but it really helps you understand what's going on. Okay, so if I'm going to plot x is 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, and y is 6, it's about here, and x is negative 1, and y is 1, 2, 3, 4 is about here. And what we have is, apparently, these are the endpoints of a diameter. So I'm going to draw a circle that has that as the diameter. So remember, there's two important things I want you to remember about the diameter of a circle. Number one, the diameter goes all the way across the circle. And number two, the diameter has to go through the center. So the center is halfway between those two endpoints. I'm going to try my best to draw a circle. It's a squiggly circle, but it's a circle. So the two things, remember, I want you to know about your diameter is halfway, the midpoint for the diameter is the center, and the diameter is twice the radius. And if we can find the radius and we can find the center, then we have our equation for our circle. It was x minus h squared plus y minus k squared equals r squared, where h and k were the center and r was the radius. Cool. Okay, so let's find our center. Let's find our midpoint. That'd be 7. What was that? 7 plus negative 1 over 2 and 6 plus 4 over 2. So that was 6 over 2 is 3 and 10 over 2 is 5. Cool, halfway there, we know our center. So the center is 3, 5, and I'll do the diameter in red. The diameter is the length all the way across. Oh, we need the distance formula. So that's going to be the square root of, that was what, x2 minus x1 squared and y2 minus y1 squared. So for us, that's going to be the square root of, let's see what goes, x1, y1, x2, y2. So negative 1 minus 7 squared plus 4 minus 6 squared. Okay, negative 1 minus 7 is negative 8 squared. 4 minus 6 is negative 2 squared. So what's that, 64 plus 4? So our diameter is the square root of 68. 4 goes into that 17 times. So our diameter is 2 square root 17. That means that our radius, remember the diameter is 2 times the radius. So the radius must be this divided by 2. 2 root 17 divided by 2, which is just root 17. Okay, cool. So now we can kind of put everything together here. We've got the center. We've got the radius. So when we put this all together, we have x minus 3 squared plus y minus 5 squared equals, oh, one of these crummy ones, square root of 17 squared. Oh, that'll turn out okay. X minus 3 squared plus y minus 5 squared equals 17.